This is off the master sheet, right?
Yeah.
So I also have the answers there too. You know that, right?
Yeah, this one isn't specifically the master sheet one though. I haven't looked at that.
So I put the answers for the master sheet on everything too.
Yeah.
Okay, so on this one, your density function is this thing, x over x squared plus y squared. And you're asked for, in your region that you're given, you've drawn it. I don't know if it came from the drawing only, but I'm guessing it's a strip of a circle with radius 4 and radius 5.
Mm-hmm.
This is x and this is y. Okay, so you need to compute this mx, which is the double integral over the region of y times rho of xy dA, and then m, or little m is what we call it, my would be this one, double integral over the region of x, rho of xy dA, and little m, which is the double integral of just the density over the region dA. So all of these need to be computed, and then your x, your center of mass, is going to be mx over little m, and check me and make sure I have it. Is that correct, these equations? This is a good one to try, because it makes you do two things at once. It makes you do center of mass and the...
I might have written them down wrong, but it says for x it's m, like big my.
Oh, that's probably right. I always forget. That's why I asked you to check.
But
everything else looks right? Yes. Okay. So I'm going to do one of them, and all of these are it's just grinding through all of these. Like it's the same work.
Yeah.
So let's just take the m. So what I'm trying to integrate, that's where you go. Obviously, this is going to be polar coordinates because it's part of a circle. So you can see like your r goes in at 4 and exits out at 5. So your r equal, let me go like this, r equals 0, 4 to 5. Those are your extents for r. And your theta would be counterclockwise this way. How far is your picture for your theta?
Just 0 to pi over 2.
There you go.
I do have a question though, ma'am. When I know this is not like the most reliable, when I plugged it in the chat, it gave me like these for like, I don't know what that is.
It's the same thing we have here.
Okay, thank you.
All at once. And then you would take the rho of xy. So now you're ready to go. You have that, and then you have r d theta is this part here is dA. And then you are starting to do this. So the x would be r cosine theta, and the x squared plus y squared would be r squared from the transformations for your polar coordinates, which you probably have somewhere on your sheet. So this is where I'm getting it from. So somewhere you should have like these formulas to transform for polar coordinates.
Oh yeah.
And then you have also dA is r dr d theta. I'd like to pirate. And then sometimes you use this one too. Tangent theta is x over y, or y over x.
Mm-hmm.
Sometimes I've had to use that. I feel like I did it in your class like that. That's it. Now you're integrating this. This cancels out. So let me follow it through here. So if I cancel the r's out, I get theta equals 0 to theta equals pi over 2. r equals 4 to r equals 5. The r's cancel, and I have 1 over r cosine theta r dr theta. Ooh, if you forgot this r for the r dr theta, you would have logs by accident, right? So they cancel out, and it's just a cosine left. So it's like super easy now.
And then integrating cosine is just
Cosine. But so let me integrate with respect to r first. If I integrate with respect to r, I just get r cosine theta from r equals 4 to 5. Like that. And then that's going to give me 5 cosine theta minus 4 cosine theta, which is just cosine theta. And now you can do your sine. So this is sine theta.
I have a question.
Theta equals this to pi over 2. And so you get 1.
For the, like, we're doing mx right now, right?
I'm just doing mx, yeah.
Did we?
No, I'm just doing this m.
Oh, just the, okay, just that.
So this is just m.
Mm-hmm.
To do mx,
Yeah.
you would have the same process.
But you would add in that
one. So you would have a times a sine, r sine theta.
Mm-hmm. Okay.
When you do the transformation.
I think I wrote it down wrong. I did like x is like you add an x and y you add a y. This is 41.
This is entirely doable. I don't remember, but if I were going to give this, and so far it's been like 100% match. Like some of the stuff I've given is almost exactly like it, but I would not give this whole thing to you. I would just ask you only give me the mass, or only give me this, and then ask. I would expect the whole thing because that's doable. This is a doable problem. It's reasonable.